What's up guys, this is Novice and I'm back with another video. So this will be actually a continuation of my password cracker series. So in the past we kind of went over how to do MD4, SHA-1, and NTLM hashes. Now today we're going to move up on how to do MD5 hashes or MD5 hashing for the password cracker. Essentially this is to teach us all how to kind of build our own tools going forward. Not only that, show that it is possible to build tools like the ones you see, like Hashcat and all the like. But with that being said, I'll go ahead and get started. So this is where we left off last time, having the MD4 class, the NTLM class, and the SHA-1 class. Now today, essentially what we're going to do is that we are going to actually add the MD5 class. So for this, let us create a new file. So here we're going to import some of the things that we imported for the other classes. So we're going to import strut, which helps us to pretty much break down or put together some of these byte and bits words. And we're actually going to import one more thing because MD5 does something interesting with how it calculates some of the values in it. And this is actually going to be the math class. Now we're gonna start it off strong, hit with a class, vector 3D, I don't know what that is, MD5. Boom. So I'm gonna start off the way we do all of them. Wow, they really are trying to get that started on me. I'm gonna start off with F in it. Boom. Oh, whoops. I believe I need parameters for password, right? So, and then password. Boom, hit that enter button. Now all we gotta do is self.password. That password is going to be equal to password. That's it. Now from here, I'm going to import some classes, or one of the classes that I know we'll need, which is going to be this left rotate one that's already highlighted. So this is perfect. Let's go ahead and copy that bad boy. Boom. All right. So we're going to need left rotate a little bit further in this when we get to our round section, but we'll get into that once we get into that. Now, next up, we're actually going to begin. So I've noticed that most of these actually start off the same way, but I'll break it down really quickly before I copy and paste it from this other, from these other classes. So essentially, we all have to start off with the UTF conversion. So with this one, it's gonna actually make the password encoded with UTF-8. From there, we append a byte. So this byte actually comes out as in the form of 1 followed by 7 zeros. Now, once that is done, we actually append the byte with, we pad it with a whole bunch of other 0 bytes until it reaches this 448 limit. Now, the end goal is to have something that is equal to 64 bytes. The reason that we stopped a little earlier is because for the final 64 bits, what we'll actually need to do is add the length as, add the length to the end of the appended zeros. Now once that's completed, we have ourselves our 64 byte block. But let's go ahead and copy that. If you guys were watching the other series, you kind of already knew that, but if it's your first time hopping in here, just a quick overview so that we can go ahead and copy this with a minimum of fuss. There we go. Okay, now from here, we also do need to actually get that 64 byte block class here. Now the reason that we're doing this is because, let's say for instance, you have a password or a list or anything that you're actually trying to get the hash for that is longer than 64 bytes. So with these being the case, instead of compressing it into 64 bytes, what we'll do, no matter the length of it, we'll chop it up into 64 byte blocks and then process each block and then go through the method that I'll show a little later. But we'll go through each of those and then put it together for our final output. But we'll need this 64-byte block one so that we can actually go through and create 64-byte blocks. If it's short enough, it'll only be one 64-byte block. But if it's longer, then it'll be broken up into multiple 64-byte blocks. So we'll get this as well. Whoops, space did the wrong place here, guys. Okay, now from here, we can actually begin our rounds. So we're just gonna call you rounds. Then we'll input, so boom. Now for these, we're actually gonna start off by, let me try to think of the way to say this. I'm gonna start these off by initializing the 4 variables we need in the beginning. So with most of the hashes, start off with a few variables, A, B, C, and D in this case. It's the same thing with the MD4, as we can see here. Let me just go back to it. And then we initialize these 4 variables, and they will be used as we go forward in the rounds. But not to worry, as we play around, transform these things with our own input and all the like, you'll see that these numbers end up mattering very little. So from there, what we're gonna do is actually grab the I don't want to capitalize, I want it like lowercase, makes everything look clean. Yep. So we're gonna pull the blocks from here so that we have 64-byte blocks. And then from here, we're gonna create our for loop. Like I said, this is for the instance where there are multiple 64-byte blocks. Even if there's one, it'll just go through this this for loop one time. But this is indeed necessary. What happened? I'm sorry, I pressed enter and it jumped all the way down to the screen, the bottom of the screen. All right, so from here, this is what we'll do. I kind of want to follow the same pattern I did here. So although you see these letters, well, they're gone now, but I'll actually use these instead because it kind of just formats everything properly. So let's see. In this next section, we are going to do something not completely different, but we're going to set up something called S. Now this S will actually be values that will determine the shift value, in the later parts of the round. But we will get into that when we get there. So we're actually just gonna go ahead and pre-populate this. So I'm actually just gonna copy and paste this from a list I have somewhere else. Let's see. Boom. Okay. So I will also come on, play with me, right? Boom. We're gonna, no, that's not it. I want to call you predefined shift amounts. All right, cool. Now that we have our predefined shift amounts, like I said, this one's a little bit different in the regards that we do have to use the math class. Now, what we're using the math class for is actually to get, as it's showing down here, sign values for numbers from 1 to 64. Now, these sign values will also be used in the transformation of the variables A, B, C, and D, as well as incorporate them with different blocks that we'll use going further. I will explain that once we get to it. But let us go ahead and label this here. So boom, and then from here we're just going to just name these as well. Compute sign constants. Oh, I am so sorry. I thought I was gonna do this later, but I actually should have done this in the very beginning. So we are actually going to break this list down into 16 4-byte words. As I said, these blocks that we use are currently 64 byte blocks. If we break them down into 16, if we break that down into 16 different words, it will give us 4 byte blocks. So we'll use those 4 byte blocks moving forward. We'll use those 4 byte blocks moving forward in the transformations that we're actually going to do for each of the 4 byte blocks, but then for each of the blocks overall, each of the 64 byte blocks overall. And now we can actually get into everything. So we're gonna, oh yeah, it already started it off for me. So here we're actually gonna get started. So as opposed to MD4, MD5 actually does 4 rounds. MD5 does 4 rounds, MD4 does 3 rounds. So with that, we're actually gonna build out these rounds in different functions, and then from there, we will be able to just call them as it relates to which round that they're in. So let's come up here. Let's see, left rotate. And I'm gonna keep the same type of way over here. So first, underscore function. And I'm gonna build it out very similarly to what I did before. Boom. Now this is the function that we'll use. Just in case of anything though, this is at the end, we are going to, yep, there we go. So this will just make sure that we get the actual, let me count this out so I'm being precise. So that's a 4 byte, 4 byte, let me see, I am tripping. So 1 byte, 2 byte, 3. So this is a 4 byte block here. So it's essentially just making sure that this is actually 4 bytes and not anything longer. All right, so let's continue onwards. Then we'll do def second function, and this one will be this function. So let me actually go back to the first function. So in the first function, what is happening is that it is going through getting whatever value of x is, which will show on the bottom pretty soon, the value of x, anding it to the y, and then taking the opposite of x. So for instance, if x was 0, 0, 0, 0, 0, 0, 0, 0, y, I said y. The opposite of 0, 0, 0, 0 would be 1, 1, 1, 1. Or if x was 1, 0, 1, 0, the opposite of that would be 0, 1, 0, 1. So it takes that and then adds it to the z value, the z variable. From there, it ORs the results from each of those AND functions, and then ANDs it to this 4 byte block here. Now, like I said, this 4 byte block is just essentially making sure that the result that returns is 4 bytes. Now we come down to the second function. It's a little bit different, but essentially you get x and you AND it to z, and then on the other side you have y, you AND it to the opposite of z, and then from there you OR those results, and then you AND it to this to make it 4 bytes as well. Third function. Now third function is a little bit different as it throws in the XOR. I forgot, operand? The XOR operation, essentially. So it goes through and XORs all of these together and then ANDs it to this to verify that it's 4 blocks. So same type of difference there. And then finally, we have the fourth function. Let's come down. What just happened? Boom, enter. I just want it all spaced out, gets me right. So here we have x and y, x and z in the parentheses. So what's gonna happen here is that we're gonna knot the z first. After the z is knotted, when I say knot, I'm referring to it being the opposite of what it was prior. So then you OR that with x and the knot of z. From there, you XOR that result with y, and then you AND it so that you verify that it is 4 byte block. So hopefully you guys are keeping up so far. Come back down here, and now we're gonna build out our functions. Like I said, not our functions, we're gonna build out each specific round. So for each round, they kind of all just go in order. So Actually, let me go ahead and tab this out. This looks about right. Okay, so for the first function, we use B, C, and D as X, Y, and Z for the first function I just showed. Now, with that being the case, X is ANDed to Y, so B and C. In this case, it would be these two values here. On the other side, the opposite of B is ANDed to D. And then from there, the results of those two, we'll call them expressions, are ORed and then verify that they are only showing 4 byte blocks. Hopefully that makes sense to you guys, but that's essentially what this is doing. Now, the value of F will become important a little later on, but that is what this first one does. Now, after it does this, let's say for the value 0, G is also put equal to 0. So down here, you can actually see what is going on. So let me see how to explain this. So essentially, what's going on in this bottom portion is that it's reshuffling each of the 4 constants, being A, B, C, and D, so that they are actually going to be shuffled each time. As you can see here, A is going to be equal to D, D is going to be equal to C, C is going to be equal to B, and B is going to be equal to this value, which is what I'm going to explain now. So first we actually come back to F. Actually, I don't particularly like that it's called F. It kind of confuses it for the F up here. So let me think of a different name. Can I just do A? No, I have an A. What can I do? Temp. No, temp. All right, we're gonna do temp. And then from here, we should just change this to temp. And we should essentially be good. So let's get started. So essentially what this is looking to do, in this temp variable, we take the result of the function here that we just got using the input of 0. Well, my bad. We take the function here using the values that we have here for B, C, and D. Now, once that result is here, it's stored into this F block. Now, A is genuinely just the value of A. So this A up here. From there, you take K of I, which if I'm not wrong, K is where we stored the signs. So it takes that, it takes the value of 0. Okay, let me explain K a little bit more. So K in the end becomes a list of values with 64 different constants. Now, simply what K is doing is it's going to each of those indexes and pulling that value. Like I said, that value is based on the sign of that of the variable, in this case being 0, adding it to 1, and then from there it actually multiplies it by a huge number, but it is actually going to be 2 to the 32nd power. I just don't remember that number off the top of my head. It multiplies that together, and then it stores that value into the list in K. Now, we retrieve that value here and add it to A, add that to F, which is this right here, and then finally we also grab the variable from X, which stores all of our 16 byte blocks. Our not 16 byte blocks, our 16 4-byte blocks. So in this case, G is equal to I. So I is 0 in this case. Therefore, it pulls out the very first 4-byte block within the 64 byte block. I know all these numbers are a little confusing, but if you try to envision it, it's just a 64 byte block chopped up into 16 4-byte blocks. And then we're using the very first one of those byte blocks in this equation, in this expression. Those words confuse me, but yes. So that's essentially what we're doing here. And then from there, like I said, we're shuffling the rest of the characters. So here, A is going to be equal to D. D is going to be equal to C. C is going to be equal to B before we transform B. So essentially, B is going to be this B right here. And then from there, B undertakes the largest transformation. B undertakes the largest transformation. So with B, it adds B to the value of temp after it's rotated by S of I. Let me find where S is. By one of these predetermined shift values. So in this case, as I is equal to 0, it pulls out this 7, and then it shifts the temp variable, whatever this ends up being, 7 bytes to the, not bytes, 7 bits to the left. And then that value is then added to B. Now, when I speak of addition in this case, we're talking about bitwise addition, not like actual addition. So that's added together and then stored within B. Now, this is gonna continuously get done throughout the rest of the rounds with just slight differences for each one. For example, in the second round, I showed you the second function before. Like I said, with the second function, you're grabbing B, C, D. Now, in this context, sorry, I'm looking at the wrong one. In this context, you're gonna grab B, and it to D, and then you're also gonna grab Y, C, and add it to the knot of D. And then you OR those together. Now from there, what changes most significantly is this G value. Now the G value, as you've seen earlier, is what we use to grab the different bytes within the 64-byte block. So in this case, it's randomizing it a little bit by using this value. However, in the end, it's actually going to grab each of the 16 4-byte blocks and then do a transformation on them. But it won't be in order as it was in the first round. Now that happens for the rest of the rounds, but they all choose their 4-byte blocks in different ways, therefore randomizing how each round does it. Now from there, after this goes through and does this 64 times, we then exit here. Let's enter one more time. We exit that for a loop. Gotta make sure I'm out of there. Yep. And then from there, we take the value of A, whatever it is after the 64 round rotation, and then store this value. So as you guys can recall, AAA is actually the original value right here. So in essence, we're taking that and adding it to the transform value of A that has been constantly shifted, that has been constantly worked on and constantly changed through the 64 different rounds. And then we're adding them together to give you the actual result of A. We do the same thing for the rest of the variables. So B, we add BB plus B. C, we add CC plus C. D, we add DD plus D. And then from there, we have our values. Now, like I said, when this is done with 164-byte block, this is the end. However, when it's not, we'll actually go back into this for loop right here. And then we'll actually change what the A is to whatever this value was, and then so on and so forth. So it's no longer going to be this value if there's multiple 64-byte blocks. So keep that in mind. So finally, we're going to exit here and do as this is actually suggesting us to do. So what this is essentially doing is that it's returning the final hash value after all of these have been ran through. So as we can see, these are all, we'll count them out together. I'm pretty sure they're all 4-byte blocks. 1 byte, 2 byte, 3 byte, 4. Yep. So it gets 4. I'm sorry, these numbers confuse me as well, guys. But we have 4 different bytes. No, we have 4 bytes of 4 blocks, each of 4 bytes that are then concatenated together to give you the final hash value for the MD5 hash. So after that is done, we have completed what we needed to. Now all that's left to do is to actually call this, and then we are complete. I'm gonna call it hash self boom, boom, and then return self dot rounds. Self. Now we're gonna remove this dot hex because we actually do that in this test one here. So now we're just gonna go ahead and save this. So we'll give it a similar name structure to the rest of them. So we're gonna name it MD5, give that a save. Now we can come into this test one and actually test out if this worked properly. So as you guys can see, we kind of have different sections doing each one. So now we're gonna have to come in here and import MD5. And then we're gonna call it, there we go. And then, boom. So this is what we're gonna do here. I'm a little confused with why they threw these random numbers at the end, but whatever. Now, we're going to run this, and then we're gonna compare this to the actual hash value that we can find somewhere online, and then verify that this works properly. Let's go ahead and run this bad boy. Boom, so it gives us something like this. Now we're actually gonna have to go through and check to make sure that this is the right value. So give me a second, guys. So we're gonna move this here so everyone can see now. Okay, so this is the hash generator. This is a hash generator that we found online. And as we can see here, it looks like the MD5 hash actually matches. And you know, it's kind of validating our SHA-1 hash as well. I just saw this here too. But so we have 5DF14. We're just gonna compare the beginning 6 and the last 6. I'm not about to go through each of these. And then 0 next. Cool. Last 6. 17C. 17C. 592. 592. So it looks like we have done this correctly. That'll essentially be the end of this video. Hopefully you guys enjoyed it and it was very knowledgeable to you guys. Throughout this entire process, honestly, I've been enjoying learning how these hashing functions actually work in different ways that we can implement it. Usually it's used for integrity, but it's also used for the storing of passwords, as you can see. But this has been a really fun experience, and I hope you guys will join me next time once we kind of finalize everything, put it all together in our actual password cracker. Like I said, my hope is that this looks kind of like how Hashcat looks, and hopefully this experience has been very valuable to you guys going through and building it out with me. But yeah, I've had a good time. I hope you guys had a good time. But that's pretty much it for me and this MD5 video. I hope to see you guys in the next one for the password cracker, the actual implementation of the password cracker. We can do that together. It's going to be a blast. And finally, I want you guys to like the videos, but that's up to you guys. If you do enjoy them, please hit that like button. If you don't like it, please just let me know what I can do better, because I'm also trying to improve myself. And finally, if you do like what I'm doing, go ahead and hit that subscribe button so that you can see more of what I get up to later in the future. Finally, love all the love, guys. I really appreciate the time that you put into even just watching this video. But I'll catch you in the next one. Novice out. Peace.